memory IO interface, interrupt interface, DMA interface, and coprocessor interface, right? So these interfaces were used for connecting the pins to the respective components of the CPU. And now we'll be discussing about the bus cycle. So bus cycle, first of all, the bus is synchronized with the clock cycle, as we have already discussed regarding this, that the clock signal which is generated by the CPU or which is available on the motherboard is synchronized with all the devices. Okay, so the clocks or the bus operations which are performed will be should be synchronized with clock cycle, and the operations are memory read, memory writes, IO read and IO writes, instruction fetch, interrupt acknowledgement, halt or shutdown. So halt or shutdown will be in the case of restart maybe, and we'll discuss this further in the next table. So the table gives us the insight regarding the operations when these operations can be performed. So the pins which are responsible for these operations are memory IO, uh, data or control, read or write. Okay, so do you remember the lock pin? A lock pin is used to lock the bus whenever there is a synchronized, sorry, no, we can't call it as synchronized, we will call it as contention for the bus. So one of the, or bus arbitration, we can say that. So the bus arbitration, whenever we have bus arbitration, so if the bus is not granted to any of the component, then the lock pin is asserted, which is active low. Okay, so we'll be checking the same here. So when the memory or IO pin is low, so it means that it is nothing but interrupt and output operation, and the no, the other pin is data or control. Again, control should be low. So if all these are low, then the bus is locked, and the bus cycle is interrupt acknowledgement. If memory IO, data and control, read or write is low, low and high respectively. So basically this doesn't occur because whenever memory and the data is low, we can't perform the right operation. Okay, so so it has been indicated as a dash over here. Fine. So the next possibility is when memory and IO is low. So IO and data and control is high. So data is read when this is low. So it is read from IO device, one of the IO devices. And the next possibility is low, high, and high for memory IO, data control, and or read or write. Okay, respectively. So in this situation, the IO data write is performed, and no bus is locked. So a question from my side is that why the bus is not locked when we are performing IO operations, that is read or write? Can anyone of you answer? Mm,
Read.
yeah, no answers at all. Fine, not an
Read.
issue.
Read.
ठीक.
Read.
So we'll move on to the next operation, that is memory read. So for memory read, the first pin should be high. Second second and third pin should be low. Okay, so we'll perform memory read operation. So when high, low and high is nothing but memory IO, data control, read or write, respectively, high, low, and high. Then there is a halt or shutdown situation. It will be halt when the address is equal to 2, and it will be shut down when the address is equal to 0. So you can observe that there are the contents of BE. BE is one of the pins, or a set of pins, which is known as bus enable. So these pins are set to high, high, low, high, and the remaining all the A2 to 31 are set to low. Okay, when the address is 2 and it is known as halt. When the address is 0, low, high, high, and high, and the address is low. When the address is 0, then the situation is shut down. Okay, so the remaining two is very much clear. So the you may say that for some time the bus is locked. Okay, so whenever the bus is with CPU, it is locked. So when there is any assertion from the components, it will be granted the bus to the components. Okay, for that, for data read, the memory IO should be high, data control should be high, and read and write should be low. For read, all should be high. We are going good, right?
So why that all the buses don't get locked when there is high low high?
Yeah.
This high low low.
High, low, low. Which one is at high, low?
मतलब यही आयो डेटा रेट जब भी परफॉर्म होता है तो बस साइकिल लॉक क्यों नहीं होती? मतलब आपने हमको क्वेश्चन पूछा बट हमको आंसर नहीं आया तो उसका answer.
कोई बात नहीं, I'll tell you. Actually, the thing is that when we are performing memory read and memory write, we are dealing with the memory. So when we are dealing with memory, then the bus should be granted to DMA, right? So the data required for this, yeah, the data required for these devices should be should require some bus access. So it will grant bus to the DMA, and the performance is done. So this process, if you remember, this is known as cycle stealing. Do you remember?
Yes sir.
Yeah, fine, good. So shall we move on?
Yes sir.
Okay. So these bus cycles can be pipelined and non-pipelined. Okay, this is very crucial, and it has been asked for many times in your previous question papers. So take it as a short question from my side. Okay, so prepare it well. The diagrams, these are the diagrams which you need to draw in the examination to score full marks. Okay, so I'll explain you one by one. First, we'll discuss what is pipelined or non-pipelined bus cycle. So we have already discussed that pipelined is nothing but prefetching the instructions, okay, consecutively, but no instructions are in same phase, right? But here, in whenever we are discussing with respect to bus cycle, we have to you know uh, discuss regarding the address and the data. Okay, we are identifying the address. If you remember the fetch cycle, we calculate the address and then we fetch the data operand. Yeah.
Yes sir.
Fine. और दूसरे भी आंसर कर सकते हैं. How many of you are online? There are 19, including me. Fine. Yeah. So these pipelines, first we need to calculate the address. When the address is calculated, they are placed on the bus, and the data fetching is done after the address calculation is done. Okay. So in that situation, we are using a non-pipeline bus cycle. So this is a typical non-pipeline bus cycle where the T1 indicates the first cycle, T2 indicates the next cycle, and the current address is nothing but n, and the next address is n plus 1. So whenever n is calculated, the corresponding n data on the nth location should be fetched by the data bus, and that is done by the in a T2 cycle. So the T1, once it is high and T1, so this indicates the address access time. Okay, which so the basically whenever if you remember the address, whenever we address calculate the address, it is placed in MAR, right? Memory address register. From memory address register, it is placed on the address bus, and address bus gets the control signals from the control. So that control will be taking the decision whether that address has to be accessed or not. and that duration is nothing but address access time. Okay, so it will take one clock cycle, so it is slightly moving towards into T2, and once the n is fetched, next cycle is fetched, that is for n+1. In T1 will calculate the address, and the address access time is there, and in T2 we'll fetch the data. So is it clear? Is it pretty much clear? I think. Yeah. Amit, any doubts?
No, sir.
Fine. So shall we move on to pipeline?
Yes, sir.
Okay. So in the pipeline, we can observe that while the T2, the data bus is fetching, this I'm indicating. I'll just note it. So here, this is the previous cycle. Okay, in previous cycle, in T2, the data n-1 is accessed. Okay, so at when the data is accessed over here, the address is calculated during T1. Okay, so you may observe that in time T1 of the current cycle, we are accessing the data of the previous cycle. Is it clear? In time T1 of the current cycle, we are accessing the data of the previous cycle. So this arrangement what we have is known as pipeline architecture or pipeline bus cycle of 386. So actually in the previous what do you call, in the previous diagram, we can see that the data is accessed only during T2 cycle. So it will require more time to access the data, and whenever the data is accessed, only when it is in T2 cycle. So it will require more time to access n+n number of cycles or n+n number of locations. Okay, whereas in pipeline there is no waiting for address calculation, in as it is done in T1 also. Okay, address and the data are in pipeline. Okay, but the data which is fetched in the current cycle is for the previous cycle, and you may observe for the next cycle here, for this particular next cycle in T1, the address is calculated for n+1, but the data is fetched for previous cycle. Okay, so this is the arrangement for which you can have the pipeline and non-pipeline bus cycles. Is it clear?
Yes.
Yes, sir.
Fine. So I hope today's lecture, today's lecture was good for you. So I'm not running it. So there is a situation where, so the third situation we need to understand is that, just a minute. So here, आप में से कोई म्यूट करेगा प्लीज, बैकग्राउंड में साउंड सुनाई दे रहा है. ठीक है. So here in the third situation, when the current cycle, in the current cycle we are fetching the data for the previous cycle, and for the next, in the next cycle we are fetching the data of the current cycle, while switching the address calculation is delayed over here. Okay, in this situation, this is bus idle state when where a bus is doing nothing. So we have to avoid this. So this is a very rare situation where bus is idle. So this can be avoided by optimization or bus arbitration of the in association with bus arbitration pins like hold and hold acknowledgement. Fine. Okay. So here the question may be asked for pipeline bus cycle, non-pipeline bus cycle, and what is bus idle state. So these are the three questions which may raise, which may be asked in the what do you call in the questions. So I hope today's lecture was fruitful for you. So by the time we'll just I'm moving for the previous section or previous session. Is it visible?
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. Fine. So yesterday we have left out a few instructions or few pins. I think we have stopped when we were discussing the error. Yes. So
सर सारे पिंस ले लो ना एक बार वापस से.
सारे pins ले लो, but it will end by
हाँ.
2:15. We have only 7 minutes. We'll do it fast quickly. Okay. Yeah.
Okay,
So
okay.
this is the pin configuration of 386. So you can the pins have been grouped according to their functionality. So the arrow which is going out is an output pin. The arrow which is coming in is an input pin. Okay.
Yes, sir.
Fine. And the arrow which has both input and output, which is data, okay, are bidirectional. Okay. And these the bunch of the ये जो solid वाला है address bus and data bus, they are group of pins, so they have been indicated in this way. So data bus in data, so we have already discussed that data can be fetched in the form of 8 bits, 16 bits, 24 bits sometimes. Okay. Exactly, I will not agree with the 24 bits. I would just say 8, 16 and 32. And the remaining the next pins are address pins. Okay. So here first 30 bits, the higher 30 bits are used for address, and the lower 2 bits are used for selecting the data bus. Okay. So the next
Yes, sir.
pins are read or write. So when it is 1, it will be acting as write operation. When it is 0, it will be acting as read operation. So we have already discussed this table in the second session. So next is data and control. So when the pin is 1, it will be acting as a data pin. Okay. And when the pin is accepting 0, then it will be acting as control the cycle like interrupt acknowledgement. So the next is memory IO. So for 1 it is memory, and for 0 it is IO cycle. A lock is nothing but locking the bus, which will not, the CPU will not allow any of the bus arbiter or bus master to access the bus. NA is the pin which is next address, which is basically used in pipelining, or you can say again the hash indicates it is NA bar, which is active low. It is active on low. So it will be having the next address which need to be fetched. So it will be pointing through whatever we have in what do you call IP. It will be notified by this pin. So next is ADS, address status bus. Address status bus is dealing with all these pins. They are read write, data control, memory IO, BE0 to BE3, which are bus enable pins. Okay. And the ready pin is nothing but ready signals indicated to the CPU that the previous cycle has been terminated and the bus is ready for the next cycle. So basically this pin is used whenever there is what do you call communication between the processor and the co-processor. Okay, so these two are the power supply pins, so we need not bother about these. So BS is nothing but bus size, which is 16. So if this is low, it will be the bus 16 will be of 16 bits. If it is 1, then it will be of 32-bit wide. So hold, we have already discussed this in DMA. Hold is nothing but requesting for the bus. If the CPU is ready to grant the bus, then it will acknowledge that with HLDA. So this is busy pin. Busy pin is used to assert that the coprocessor is allocated a task. So it will be asserted by the CPU. As you may see that the busy pin would be the output pin. Where is it? Coprocessor interface. Yeah, sorry. Busy pin will be the input pin. So which is taking the signal from the coprocessor. Error, whenever there is an error with the coprocessor, then it would be indicated by error. PE request is processor extension request, which is an output pin. So it will send the request through this pin. It will send the request through this pin. INTR is interrupt request. NMI is non-maskable interrupts. NC is no connection. So I hope all the pins are covered. So we have done
Yes,
with
sir.
session 1 and session 2. For session 3, we'll be having, I'll notify you on the group, which will be conducted on Monday. Okay.
Yes, sir.